Hello everyone, welcome back again. In this series, the aim of this series is to give you confidence that even the difficult problems in CSAT can be solved under a minute if you follow the right approach and focus on the basic principles. Now, in the recent years, people started worrying when they are seeing reminder theorem questions. Now, in this session, we are going to solve using the same concept that we have used before, which is attack point approach and basic principles, seeing even how reminder theorem problems can be easily solved. Let's start ahead. He is asking what is the remainder if 2 to the power of 192 is divided by 6. Okay, 2 to the power of 192 divided by 6. There is a unique property, especially between 4 and 6, which tells that you divide 4 anytime by 6. Suppose 4 to the power of 1, which is 4 by 6, gives you a remainder of 4. Consider 4 square by 6, which is 16 by 6. You will get a remainder of 4. 4 cube, so on. So, can we use that property here? Because 2 is given and even our power is an even number. So, we can write this in the following way: 2 to the power of 2 whole power 192 by 2 by 6, which is nothing but 4 to the power of some power x by 6, and we know from this property it is always 4. Such an easy problem if you know the pattern and where to attack. The attack is this being an even power should give you one hint, and 2 and 6 should give you another hint. One more way to solve this problem is by using the concept of negative remainder. Negative remainder and common by taking common between, because 2 and 6, 2 is common, by taking that outcome, but it's a bit lengthy procedure, but this is a more important way or efficient way to solve this problem. So, the answer is 4. Next, if today is Sunday, then which day is exactly on 10 to the power of 10th day? So, we all know that although this may seem to look like a calendar problem, this is actually a remainder theorem problem. We know days are a multiple of 7. If you even have a basic understanding of calendar problem, we know that we solve days by using odd day approach. Odd day approach is nothing but we see number of days that are left out when divided by 7, and from there on we calculate. Same way here, 10 to the power of 10 by 7. We know that 10 is divisible by 7. So, first do that. Next, it gives you 3 to the power of 10 divided by 7. Now, we can't move forward because 3 is less than our 7. So, we need to do something such that this becomes more than 7. How can we do it? 3 square is more than 7. So, 9 to the power of 5. This is nothing but 3 to the power of 2, 5, which is nothing but 9 to the power of 5 by 7. Now, this is 2 to the power of 5 by 7, because remainder is 2 here. 2 to the power of 5 is nothing but 32. 32 by 7. So, the remainder is 4. So, there are 4 odd days. If today is Sunday, there are 4 odd days between this day and this day. So, if today is Sunday, Monday, Tuesday, Wednesday and Thursday, 4 days. So, Thursday is the answer. Simple. If you know the basics, just that is enough. Now, see, these all are, mind you, from those CSAT papers where people have started, when people have started considering them difficult. All are from those recent years. It is not like I am giving you previous questions from the past years. These are much relevant, and you see we are able to solve less than 1 minute. Now, see here, question is this long. How do we do normally multiply? Suppose 2 into 4 and 2 into 3 are there. How do we divide? Normally we cancel the common parts here. Same way do it. 85 into 87 into 89 into 95 into 96 by 100. The solution will not take the time I have took for even writing. What is 100? 100 is nothing but 2 to the power of 2 into 5 to the power of 2, which is nothing but 4 into 25. 4 25s are 100. I have expressed just them in prime factorization form. Now, can we get 2 5s here? Yes, there is one 5 here. There is one 5 here. So, this is getting cancelled. 95 is not getting cancelled, but there is some number into 5. This is some number into 5. This is some number into 5. All I am interested, because solving the problem is important and efficiently is also important. So, my 5 is here, these two 5 get cancelled. Number next 2 squared. We know that this is also 4 into y, 24, I think 24 4s are this. So, 4 and 4 get cancelled. So, since the whole denominator got cancelled, the remainder is 0. How much time has it taken? It is just seeing the common things in the numerator and denominator and cancelling them out. Next. Same here, this is a 2022 problem. 92 into 93 into 94, 95 into 96 into one heuristic I give you when solving particularly remainder theorem problem is try to see them in terms of primes. That will be much easier by 1, 2, 6, 7. Now, this is a bit complicated, but if you think through it, is it that complicated? What is the heuristic I told you? First, start with primes, okay, for 3, because this is anyhow 1, 2 is not possible. Next 3, this is 3, 6, 9 and plus 1, 10. So, 3 is also not possible, but the unit digit is 1. How many tables give you 1 at the end? It is obviously 3 into 7 is one of the possibility. So, instead of going to 5 and checking 7 and all, first check for 3 itself, because it lessens your burden, because 1 is there. Just take a guess, because unit digit is 1, that means somewhere 3 into 7 should be involved in it. So, we saw 3, what is the next prime number? 13. Now, try this by 13, I think this is 13 into 97, okay, 97 cancelled and 13 7s are 91. So, since it got cancelled, remainder is 0. Next, if 3 to the power of 2019 is divided by 10, what is the remainder? How do you solve this? I always told you remainder is the distance from the nearest multiple. Suppose, let me explain the concept here. Suppose 9 by 2 is there. What is the remainder? 1. How do you visualize this? 1, 3, 4, 5, 6, 7, 8 and 9. 1 is the remainder, 4 is the quotient. Got this? Now, we are dividing it into blocks of 2. 1, 2, 3, 4, 5, 6, 7, 8. So, 9 is left out. The distance from the nearest multiple is 1. So, that is the remainder. What is the another way of saying this? Since I said it is distant, it is 1 distant from here. It is also, what is the next nearest multiple? 10. 2 5s are 10. So, it is also distant. So, remainder can be measured in 2 ways, either positively or negatively. This is -1. Okay. Now, I will give you a short trick. Why I am using the concept of negative remainder is because I am comfortable always dealing with 1. even if the number is less, see, even if the number is less, if it comes in 1 plus 1 or minus 1 range, I can easily do the powers of 1. So, that is why the negative remainder concept is being applied here. So, always positive remainder is equals to divisor plus, okay. What is the negative remainder of 9? 1 minus 1. What is the divisor? 2, which is 1. Take any concept like this. Let us take one more example. Let us take 13 by 4. Positive remainder is 1 because 4 3s are 12 and 1 is remaining. This is positive remainder. What is the negative remainder? Same. See the nearest multiple greater than this. 4 4s are 16. So, minus 3, 16 minus 13, 3. This is the negative remainder. As I told you before, positive remainder is equals to divisor plus negative remainder plus minus 3. Okay, got this? If you know the concept of negative remainder, see how easy it becomes. So, this is 2019. What is the nearest power which is just 1 less than 10? It is 9. So, what I will do? I will multiply 3 into 2018 by 10. Can I write like this? It is just basics of exponent. A to the power of m into a to the power of n is equals to a to the power of m plus n. So, I have expressed here. Now, divide this by 2 and this by product is 2. So, now what does it happen? 3 into 9 into 2018 divided by 2 by 10. How much is this? 2 ones, zeros and 9. Since this is odd and this gives you a negative remainder. So, how can you write this furthermore? So, minus 1 by 10 into, since this is an odd number because 2018 divided by 2 will give you an odd number. This will be minus 1. So, 3 into minus 1 minus 3. So, minus 3 is the remainder. What is the positive remainder? 10 plus minus 3, which is 7. It is easy if you go through the concept of negative remainder. It took this long because I explained you the concept of negative remainder before and then we came here. But at the instance you see this 3 and 10, you can easily divide this by 2 because you will get an odd digit. You will get minus 1 here, 3 into minus 1, minus 3 plus 10. Hardly 1 minute. Next one. What is the remainder one? 51 into 27 into 35 into 62 into 75. Is divided by 100. You see 5s are available here, but just like we dealt with the previous problem where we got this as 2 2s and 100 as 2 2s and 2 5s. 5s are available, but 2s are not available here. So, that approach may not lead to work here. Now, you see, he is asking the remainder. Remainder always depends on unit digit, right? If you want last digit, then divide by 10. Suppose remainder 29 by 10. What is the remainder you get? 9. So, it always depends on the last digit. Okay. Now, he is asking 100. 100 means last 2 digits of this product is needed because that will be the remainder. When you divide it by 10, that last digit will come as remainder. When you divide it by 100, the last 2 digits will come as remainder. Got this? Now, let's take a blind shot and see what are the product of all unit digits. 7 into 5 into 2 into this thing. 7 5s are 35. 35 into 10. Oh, now you see 350. If you do multiplication anytime, only one bit is carry. Here, considering the unit digits itself, we are getting a 3-digit number. That means last two digits are fixed, and this gets added to next number. So, since we are already getting to know the last two numbers, we need only this, because for 100 and remainder, we need last two numbers. Since there is only one carry, 3 becomes carry, 50 is the last 2 digit, so 50 is the answer. If you are confused, let's see. I'll give you an example. Suppose we get 13 into, suppose 43. 13 3s are 39 plus. You see, carry gets added to the 13 4s are 52. When you do a product, only carry is getting added to the next terms possible. Whatever is there in the unit digit is coming down like that. Okay. So, in any product too, carry is always 1. We are applying the same concept here, because to find the most efficient way, I have just taken a guess based on multiplying last unit digits. Once we done that, since we are getting a 3-digit number, we need not even go forward, because we take 3 as carry, 50 is the answer. So, answer is 50. Once again, just like in the previous sessions, you get only see the attack points and basic principles. There is nothing we have discussed. Even if you see from the first problem, this is just a property of 4 and 6. Next, basic remainder theorem. This is just cancellation, which we would have learned in first or second class. This is same cancellation again. So, no matter the problem, if you are good in your basics and you are following the approach that needs to be followed, instead of by hearting some processes or remembering shortcuts, UPSC, CSAT, particularly CSAT, has always been easy. So, always focus on your attack points and your basic principles, and when you do that, problems are solved just in an instant.